So basically, we are trying to apply this current quantum computers to mostly financial problems. So optimizing things like portfolios or improving trading models, and also something called anomaly detection, which is a potential quantum advantage for detecting like things that are outside the norm, which could be important for things like fraud or hacking banks and whatnot. And so the main thing is that we're trying to figure out ways that we can give at least an on-ramp for what we believe is going to be a huge revolution in technology and in finance in the future, and then try to provide advantage now to companies. And then as the hardware becomes more powerful and scales up, and also the algorithms become more powerful, then we'll grow with the technology. I mean, I'll just say the killer app for quantum annealers right now anyway is portfolio optimization. So this is something that a lot of banks have a lot of interest in, because selecting an optimal portfolio with many different securities, whatever you're trading, is actually like fantastically complex problem, which is not really solvable efficiently with a classical computer. So there's one really cool thing about quantum, which I think is going to get your listeners really interested, and me and everybody, is that there's all this uncharted territory. There's there's probably all sorts of things out there are just waiting to be discovered that a quantum computer will be able to probably handle a lot more easily than a classical computer. I think there's a couple, but it's the idea that it's going to replace classical computers. And I strongly, although I can't say for sure, I don't believe that it's going to replace it. I think they will act together. They will complement each other. In the short term, it's overhyped, and in the long term, it's underhyped.